Okay, so let's have a look at the Leaving Certificate Higher Level Maths Paper 1 for 2015, question 4. So this is it here, and it's a complex numbers question. So the complex numbers Z1, Z2 and Z3 are such that 2 over Z1 is equal to 1 over Z2 plus 1 over Z3. So we're given Z2 and Z3, not Z1, so we've got to find what Z1 is, and we've got to write it in the form a plus bi, where a and b are integers. Okay, so let's write it out. We've got 2 over Z1 is equal to 1 over Z2 plus 1 over Z3. Now we're given Z2 and Z3, we're not given Z1, so we should be able to isolate Z1. So let's see, Z2 is 2 plus 3i, and we've got Z3, which is 3 minus 2i. And we don't have Z1, so we should be able to just mess around with this, get Z1 on its own, and simplify the complex number that we end up with. So let's start. So the first thing I'm going to do here is just add these two fractions on the right hand side here. So our common denominator here will be 2 plus 3i, 3 minus 2i. Okay, so what did I do to this 2 plus 3i here? I multiplied it by 3 minus 2i. So I must multiply the top by 3 minus 2i. So 1 times 3 minus 2i is just 3 minus 2i. Okay, I've got this plus here. And then what did I do to the 3 minus 2i down here? Well, I multiplied it by 2 plus 3i. So multiply the top part here by 2 plus 3i. That's just going to give me 2 plus 3i. Now, just be a little bit careful here. If this was a minus here, if this happened to be a minus, I would just put these in brackets, because if this was a minus here, that minus is going to change this to a minus 2, and also here a minus 3i. It's a very common mistake to leave out these brackets or not change both of these signs here. But as it turns out, it is a plus, so we don't have to worry about that. But in other questions, you might have to. Okay, so let's just simplify the top here. We get 3 plus 2, which is 5, and we've got minus 2i plus 3i, so that's plus I. I'm going to multiply out the bottom part as well here. So 2 3 6, 2 times minus 2 is minus 4i, 3i times 3 is plus 9i, and then here we've got a plus times minus, which is minus 2 3 6i squared. Okay, just to finish that off, then we've got 5 plus I, and on the bottom we end up with 6. Now remember that minus 6i squared is just going to be minus 6 times minus 1. I squared is minus 1, which will give me plus 6. So 6 plus 6, this 6 plus this 6 here will give me 12, and I've got minus 4i plus 9i, so that just gives me plus 5i. And remember, that's equal to 2 over Z1. Okay, so next step then, I've got a fraction here equal to a fraction. So what you can do here is just simply cross multiply. Multiply the 2 by the 12 plus 5i, and then the Z1 by the 5 plus I, and they're both equal then. Effectively what you're doing here is multiplying both sides by Z1 times 12 plus 5i. But this is kind of a quick way of doing it. Top times bottom, bottom times top here. Cross multiplying. But you can only do that when you have a fraction equal to a fraction. Okay, so let's multiply this out. So we've got 2 12s, 24, plus 10i here. And on the right hand side we've got Z1 times 5 plus I. Now I'm going to divide across. Remember, we want Z1 on its own, so I'm going to take this 24 plus 10i, divide by 5 plus I, divide this side by 5 plus I, and we've got the Z1. So this is our answer here. However, it's not in the form that they wanted. They wanted in the form a plus bi. So we've got a complex number divided by a complex number. So the way you tackle those is that you take the 24 plus 10i over the 5 plus I, and then multiply by the complex conjugate of the denominator here. So the denominator is 5 plus I, so we multiply by 5 minus I divided by 5 minus I, and that's equal to Z1. Remember, all we're doing here really is just multiplying by 1. 5 minus I divided by 5 minus I is just 1. When you multiply anything by 1, you don't change it, so we haven't changed this fraction. Okay, let's continue on then. You got to multiply the top by the top, the bottom by the bottom. So the top by the top is 24 times 5, which is 120. 24 times minus I is minus 24I. We've got 5 times plus 10I, so that gives me plus 50I. Plus times minus is minus 10I squared. All of this over these two multiplied. Now if you look at these, really what we've got here is 5 plus I times 5 minus I. That's really just the difference of two squares. So it's really just the first term squared minus the second term squared. So that will give me 25, and this is minus 1. I squared is minus 1, so we just get 26. Minus is plus. I'll just do it the long way here. We multiply out the 5 by 5, we get 25. Multiply 5 by minus I, you get minus 5I. Plus I times 5 is plus 5I. You can see here the i's are going to cancel, which is perfect. And then we've got plus times minus, which is minus, and then you got your I squared here. Okay, so let's simplify the top and the bottom. Well, we've got 120, and we've got this minus 10I squared. Well, minus 10I squared is just going to be equal to minus 10 times minus 1. So that's just going to be 10. So 120 plus 10 is 130. You've got minus 24I plus 50I, so that's plus 26I. That's all over. Now again, we have a minus 5I plus 5I. We would expect those to disappear, and they have. It's 0 there. And we've got this 25. This is going to be plus 1. This is a minus I squared, which is minus 1, which is plus 1. So we have 25 plus 1, which is 26. So we're almost there. Remember, this is equal to Z1. This is equal to Z1. So now we've got to write this in the form A plus BI. So 130 divided by 26 is 5. 26 divided by 26 is 1. So we just get 1I, and that gives us our Z1. So that's Z1 in the form A plus BI. Okay, so that's that one done. Let's have a look at part B then. Okay, so we have a complex number here, this W here. Well, it's actually Greek letter omega, and it's a complex number such that omega to the power of n is equal to 1, and omega itself is not equal to 1. Now we have this equation here, s is equal to 1 plus omega squared plus and so on up to omega to the power of n minus 1. Use the formula for the sum of a finite geometric series to write the value of s in its simplest form. So it's telling us what to do here. Use the sum of a finite geometric series. Well, that formula, it's in your maths table, so it's just a times 1 minus or to the power of n over 1 minus or. Now in our particular case, we have this series here, 1 plus omega squared plus all the way up to omega to the power of n minus 1. Now here we need a, we need or, and we need n. So a is our first term. Our first term is 1. What do we multiply each term by to get the next term? Well, if we multiply 1 by omega, we get omega. If we multiply omega by omega, we get omega squared, and so on. So that's going to be our or. How many terms are there? Well, we can see here we've got to the power of n minus 1. Or our first term is omega to the power of 0. Our second term is omega to the power of 1. Our third term is omega to the power of 2. So our n minus 1th term is our nth term rather is omega to the power of n minus 1. So we have n terms here. We have n terms here. So n is equal to n. Okay, now let's just stick those into our formula here. So a is 1. We have 1 minus our or here, which is omega. Our n is to the power of n. Our n is n. and then we've got 1 minus our or down here as well. Okay, so what do we do now? We can't really do any more with that other than take away this 1 here, because it's just going to be 1 minus omega to the power of n over 1 minus omega. So we can't do any more with that. Now we are, however, told that omega to the power of n is equal to 1. So our complex number raised to the power of n is 1. So we can put that in there. We have an omega to the power of n, so it's 1 minus 1 over 1 minus our omega here again, and that then is just going to give us our 0 over 1 minus omega, and that 0 over anything is just going to be 0. And that's really it. I mean, it says use the formula for the sum of a finite geometric series to write the value of s in its simplest form. Well, there you go, that's it there. It's just 0. Okay, well that's it for question 4.